sine beta t, that is, when we have f of t to be equal sine of beta t, now the Laplace transform of it, how are we going to find it? Now recall, from Laplace transform of f of t that equals integral from 0 to positive infinity f of t exponential raised to minus st dt. Now let's substitute the value of f of t that equals sine beta t here and see what will happen. So what we are going to have is the Laplace transform of sine beta t equals, when you substitute your beta t here to this here, it will be integral from 0 to positive infinity sine beta t exponential minus st dt. Now we can name this to be equation 2. So if you name this one to be equation 2, now when we recall from equation 2, to solve the type of this integration, we can say it is an integration by parts. When we have this, so it is an integration by parts. This one is an integration by parts, and we can say let u to be equals sine beta t. We can let u to be equals sine beta t and the phi to be equals exponential raised to minus st dt. Now from here, we want to obtain from here du dt will be equals beta cos beta t. Now also, we want to obtain phi. From here, our phi will be equals minus, you can say, when you want to obtain our phi, we can say d phi, the integral of d phi will be equals the integral of minus exponential minus st dt. We believe that this will cancel this. We have phi to be equals minus exponential minus st all divided by s. So now, since we know that we want to solve this integration, which equivalent to integration by parts, and the integration by parts says that integral of u d phi equals integral of u phi over the range of 0 to positive infinity minus integral of v du. So now from here, we have our u to be equal sine beta t. Therefore, we are going to have it to be integral from 0 to positive infinity. Our u equals sine beta t. Then our d phi equals this. Equals, what is our u? Our u equals sine beta t. Now our phi equals this. All divided by s over the range of 0 to positive infinity. So minus integral from 0 to positive infinity. Our phi equals this. All divided by s. Now our du equals, from here, our du will now be equals beta cos beta t. Then we have it to be dt. So when we try to obtain, So from here, our du will be equals beta cos beta t dt. So now from here, what we are going to have is integral from 0 to positive infinity sine beta t, then exponential minus st dt equals, now for this one, at t equals infinity, everything here will be equal 0. At t equals 0, everything here will be equal 0. So we have for this part to be equals 0. Then we are going to have it to be plus. Because we have it to be minus here, we have minus here. Everything here will be plus. So we can factorize this beta out. We have it to be beta divided by s. Then we have integral from 0 to positive infinity. We have it to be cos beta t exponential minus st dt. So what we are going to have for this is beta divided by s is integral from 0 to positive infinity cos beta t exponential minus st dt equivalent to integral from 0 to positive infinity sine beta t exponential minus st dt. So when we name this to be equation 3, mind you that we want to solve this integration that we have in equation 2. So now this equivalent to, we have this one to be equals Laplace transform of sine beta t to be equals beta divided by s integral from 0 to positive infinity cos beta t exponential minus st dt. So we can start this. We have not done with it. So now the next thing is from equation 3 that we have here, from this equation, we also want to obtain the integral of 0 from 0 to positive infinity cos beta t exponential minus st dt. So this one is also integration by parts. So to solve this, we can say let u to be equals cos beta t and the phi to be equals exponential minus st dt. Also from here, the u dt will be equals minus beta sine beta t for this when we find the first derivative of cos beta t. Now also we want to obtain phi by taking the integral of both sides. We have integral of the phi equals, so from here we have integral of the phi equals integral of this. So integration will cancel, differentiation we have phi to be equals minus, when you take the integral of this by using integration by substitution, you have exponential minus exponential raised to minus st all divided by s. Now let's substitute everything here using the integration by parts formula. So now we have this integration by parts expression by substituting the value of u here, the value of the phi, which equivalent to this. So we are going to have it to be integral from 0 to positive infinity. Our u cos beta t, our phi exponential minus st dt, and this will be equivalent to integral of u cos beta t. Now we have it to be phi equals this minus exponential minus st all divided by s over the range of 0 to positive infinity, all minus integral from 0 to positive infinity, then our phi that equals minus exponential minus st all divided by s, then our du that equals minus beta sine beta t dt. So from here, by substituting the upper bound at t equals infinity, what we are going to have is we are going to have it to be 0. Also, at t equals 0, then everything here will be equals 1. So we have it to be plus 1 divided by s. So from here, we have minus integral from 0 to positive infinity. So this will change to plus. We have beta divided by s. So now from here we have 1 divided by s. By factorizing this one outside, we have beta divided by s, the integral from 0 to positive infinity, sine beta t, then exponential raised to minus st, we have it to be dt. So we have, therefore, we have integral from 0 to positive infinity cos beta t exponential raised to minus st dt to be equals 1 divided by s minus beta divided by s, the integral from 0 to positive infinity. We have sine beta t, then exponential raised to st dt. So from here, we can substitute this integration that equals this one in equation. By substituting it in equation 3 here, this integration we have here, we are going to substitute it. Therefore, recall from equation 3. So when we recall from equation 3, we have it to be this. Then we have this integration to be equals this one. So we can substitute it here. What we are going to have is beta divided by s all into bracket of, we have 1 divided by s minus beta divided by s integral from 0 to positive infinity sine beta t, then exponential raised to minus st, we have it to be dt here. Then also we have everything here to be equals integral from 0 to positive infinity sine beta t exponential raised to minus st dt. So this integration and this, they are the same. So we can let them to equals I. When this one equals I, let integral from 0 to positive infinity sine beta t, then exponential raised to minus st dt to be equals I. So this implies that we have I to be equals beta divided by s into bracket of 1 divided by s minus beta divided by s, then we have it to be I here because we have it to be I. So now what we are going to do now is open the bracket. We have beta divided by s square. For this we have beta square divided by s square, then we have it to be I. So from here we have I plus beta square I all divided by s square to be equals beta divided by s square. So we can factorize. From here we have it to be s square I plus beta square I, everything equals beta divided by s square. So from here, what we are going to have is factorize I. We have I into bracket of s square plus beta square all divided by s square to be equals beta divided by s square. So to make I as the subject of the formula, we can divide both sides by this expression we have here. So what we are going to have is I equals beta divided by s square all divided by s square plus beta square all divided by s square. So from here, we have I to be equals beta divided by s square. Once you change this one to multiplication, now numerator will change to denominator. That is, we have here to be s square all divided by s square plus beta square. Look at it, this one we cancel this. So what we are going to have is beta divided by s square plus beta square equals I. But note that our I equals integral from 0 to positive infinity sine beta t exponential minus st dt equals I equals beta all divided by s square plus beta square. So now, recall from the question 1 that this is the Laplace transform of sine beta t. This one from equation 1 here, therefore, the Laplace transform of sine beta t that equals integral from 0 to positive infinity that equals integral from 0 to positive infinity sine beta t exponential raised to minus st dt equals beta divided by s square plus beta square. And that is the final answer for this. Anytime when you have the Laplace transform of sine beta t equals beta divided by s square plus beta square, So if you are new here, watch this video. Don't forget to subscribe to my YouTube channel and follow me on my Facebook page. Now let's take a look at the example under this. Assuming we have the Laplace transform of sine 3t, so our answer will be equals, our 3 here equivalent to beta, we have it to be 3, all divided by s square plus 3 square. Then this will be equals 3 divided by s square plus 9. Bye.